Project 3 covers environment variables found in RAM of a computer system, and also some basics into shell scripting. Let's first look at environment variables. The set command runs on most operating systems and will show you information in memory that applications need. An example, an application might want to determine if you prefer light mode or dark mode. That could be an environment variable setting. So when you launch the app, like Facebook, it will display in your preference. The lab wants us to also look at environment. So exported settings, the most common ones here that applications will look at. So the operating system will use both environment and set variables, so applications know how to load. It wants us to look at which one is larger. When I issued the commands, I had multiple pages with the set command, and here with environment, only a single page. One of the more common ones you'll deal with would be the path. Let's get an exact size difference. I'll use set and I'll pipe it to word count, as we've done in a previous lab using the pipe and word count -L. I'll reissue the command, but this time with the env command. So we have a difference of 36,000 or 3,000 and 27. So quite a large difference between the two. Let's echo $PS1. This is the variable that tells how the prompt should be displayed on the screen. We show the user, an @ symbol, the host, and then the working directory. You can modify this. In the lab, they want to set PS1 just equal to some silly text. So now we see our prompt is being displayed via what is in the PS1 environment variable. I'm going to exit, as I prefer my standard default prompt. I'll log back in. You can create your own variables by typing in a word, setting it equal to some value. Again, we'll just put some silly text in. Accessing a variable, as you see, I've been using a $sign in front of the variable names. That tells the operating system to look in memory for a name called myvar and display the contents. Applications can do the same. If I was to launch another bash shell prompt from this point and press enter, now I have two bash shell prompts launching. I can't really see it on my screen, but I have a parent bash and now I have a child bash. If I try to view the environment variable, it is blank in the second bash shell script. Or I should say second bash shell. If I exit, I'll be back at my parent, echoing the variable. If I spell the echo command correctly, I can see the contents. To be able to view a variable with child bash shells or child programs that launch off of the command line, you have to export the variable that you create. Now if I spawn a child application, or in this case a child shell, you'll notice this time, using the echo command, the value is available in both the child and parent. I will exit again. You will not set, on a typical system, variables at the command prompt. You will store these commands in a file, the global file, under the etc folder called profile. This is loaded at boot time. Reading the comments throughout this file, I say you should not edit this file directly, but rather create a custom.sh file under the etc folder and profile.d directory. There are already several other files in here. So creating a custom.sh file and adding environment variables to adjust your operating system. That way future upgrades or patches to the system that might potentially overwrite these files would not affect your custom file that you create. You could also set environment variables and export them per user that logs into the system. Each user's home folder has a hidden file called .bash_profile. So you could edit that file, create a variable, and then use the export command with the variable name. So every time you log in as that user, the variable will be available to all applications. So let's go ahead and look at that, setting it for every time I log in as root, the my variable will be there. First, let's double check. Echo my var shows my sample variable. If I log out, log back in, it will not be persistent, meaning echo my var will be blank. So to be persistent, let's go ahead and edit the .bash_profile. I'll go to the bottom of the file. I'll use O. I'll export my variable equal to the text I want. In this case, my sample variable. Save the file. If I try to echo the variable at this point, it will still be blank because I've not logged in after making changes. I must exit. Log back in. Look for any error messages that might appear from a typo in the bash profile file that I modified. No error seen. Try to echo my var again, and I see now that I have my sample variable printed to the screen. It is also possible to have aliases. They are similar to variables. Let's type alias. These are all set by the distributor of the Linux system that you're running. They're basically shortcuts. One popular one that Red Hat likes to implement is LL. It's in the middle of the screen. It runs ls-l and turns on colorization. So my directories are in blue. It gives me the permissions, the owner, timestamp. It's just a shortcut for typing ls-l. It's not good to use aliases in creating your own. As you log into a different distribution of Linux, they may not have it implemented, and the aliases that you get used to won't be on another person's system. So you may have difficulty remembering what is the actual command to run. Let's create a simple alias called asample. We'll set it to run several commands. We'll look at the etc directory. We'll have it cat host. We'll change back into our home folder and run an ls-l. So we just simply created an alias to run 4 different commands at this in sequential order. Typing the alias name and pressing enter, we'll have changed into the etc folder, viewed the host file, changed back to our home folder, and view the contents of our home folder. Again, take a screenshot at this point, and remember, don't go around and fill your system full of aliases. Let's move forward and look at creating a sample script file. Use the Vim editor, creating a new file called MyScript. The first line in the script will contain the shell interpreter meant to execute the script. And this is a lot of times shortened to shebang. So I'll hit I on the keyboard. Instead of trying to say pound exclamation point /bin/bash, you'll hear coders call them a shebang line or maybe a hash bling. Now let's actually write bash code. We'll use the echo command -e, and we'll write this is a sample shell script, period. \t. This will insert a tab. This is the reason we added a -e to the echo command, so that it will look at special code. So tab complete, maybe carriage return, new line, other such things. Let's continue with the rest of the text. The lab has us put a -a. I'm going to omit that. That is just simply a beep on the screen. And I don't really care about the computer making sounds at me. Now I'll issue a command to view the file system information. So really simple script. Echo something to the screen. Run a command to display the mounted file systems. Let's save the file. Now let's look at the file that we created with the ls command with the long listing. The permissions on it are read write and read for group another. There is no execute permission. There's 2 ways to run the script. One is using the bash interpreter followed by the file name. This executes the script, shows us the text. Notice there's a tab between the 2 sentences. And then it displays out the file system information. If I try to run the script without using bash and without setting permissions, I get a permission denied. Let's fix that. Let's change permission, chmod 744. So 7 is going to turn on read, a value of 4, write, a value of 2, and then execute a value of 1. So 4, 2, and 1 adds to 7. 4 and 4 will leave the read for group and others on the system. I'll view the permissions again just to verify RWX is set. The file is also in green, letting me know that it is an executable. Now if I try to type /myscript and press enter, it will execute. I'm not able to type simply myscript. Linux only looks in the path statement environment variable when you type in a command. If the command is not located in one of the folders that's stored in the environment variable path, it will not execute. Let's echo path to the screen and look at what folders exist. So there's 1, 2, 3, 4, 5 folders. None of these contains /root. There is a /root/bin, but my script is simply in /root. So it does not execute. The // if you remember, a period means current directory. So that's what the // means. Dot is current, / means directory. So we type ./myscript. So current directory, run myscript. It's a safety measure in case you download a tool that may be named such as ls. That's a virus, and you put it in your home folder. A user commonly typing ls to list will not accidentally execute a wrong or a virus also spelled ls. It's not located in the proper folder. At this point, you're not a shell coding expert, but at least you see what coders are going to or have to experience. Let's go ahead and exit out. And this is the end of the lab.